I need you guys to be quiet. All right, 10th graders get started in about a minute. Go ahead and get your homework out. And we'll go over that first. All right, here we go. Any questions on the homework before we grade it? Any questions? So it was that ugly table, and then 18 and 19 might have been the only challenging ones, but they weren't too bad. In fact, 18 and 19 you could do with just by thinking about it, not without actually doing any calculations. Any questions? All right, grade your homework. I'm gonna do this very quickly. Let's see. Number one is, now they're gonna give you lateral area, total area, and volume. So number one, LA is 40 pi, total area or surface area is 72 pi, and volume is 80 pi. Number two, LA is 160 pi, TA is 288 pi, and the volume is 640 pi. Number three, LA is 24 pi, TA is 56 pi, and volume is 48 pi. Number four, LA is 240 pi, TA is 368 pi, and volume is 960 pi. Let's see, number five is 4, number 6 is 1.5, number 7 is 48 pi, number 8 is 5. Now on to the ugly table. So I'm going to read this from left to right for the answers. Most of these have either 4 or 3 answers. Number 9, slant height is 5, LA is 20 pi, TA is 36 pi, and volume is 16 pi. Number 10, slant height is 10, LA is 80 pi, TA is 144 pi, volume is 128 pi. I'm going to grade whatever you turn in through 16, and I'm just going to call out 18 and 19. So I'll grade the ones that I did not call out. Number 18, the wider one, the short cylinder holds more. Its ratio is 2 to 1. And 19, that ratio is 1 to 3. Now, they didn't really say how to give the ratio. You could have done small to big or big to small. So either 1 to 3 or 3 to 1, either one was fine. All right, make sure you turn these in on Teams. Don't get lazy on your homework. All right, here we go. Today, let's see, the calendar I think is accurate now. So we're going to finish up chapter 12 on Wednesday. That's tomorrow. We'll do 2 days of chapter review, Thursday, Friday. We'll get that 3-day weekend, and then we'll come back. We'll take the chapter 12 test. As always, the chapter review is not sort of kind of like the test. It is exactly like the test, other than I changed the numbers. So if you understand the chapter 12 reviews, you'll do fine on the test. Today's our last formulas. No more formulas after today. Tomorrow we'll get a concept, but no formulas. And today's formulas are things you saw in the 8th grade as well, too, if you remember way back when. You guys are going to come back on Tuesday after quarantine, take that chapter 12 test, and the very next day is PSAT. We're going to do no more PSAT review. That will be a half day. Tuesday is a full day, normal day. Wednesday is a half day for you. Come in and take your PSAT test, and then you will go home. And then we start our second to the last chapter, which is chapter 13. We'll get all the way through chapter 13. There is a chapter 14 in the book, which is an optional chapter. I will teach as much of it as we have time. And we're getting really close toward the end of school, so that's a good thing. Here's your homework tonight. Copy it down, please. The part where I said, be quiet. You guys are doing horrible. 10th graders, I've got a bunch of 3rd and 5th graders in my classroom right now. They're here because they're not taking the CMAS test. So you might hear some noise, maybe you won't, but if I say any weird comments as I'm talking to them. All right. Here we go. Today we're going to be talking about spheres. We're going to get 2 formulas for spheres. And by the way, these formulas are the same formulas that you learned in 8th grade, so nothing new here. Write this down in your book of truth, please. Sphere, the definition of sphere. Now, we did this definition before. The chapter we had on loci or loci, we had this exact definition. So a sphere is the collection, it's 3D, and it's a collection of all points that are equidistant from a given point. So you start with the center of the sphere, you measure a certain distance out away from that sphere in 3 dimensions. Eventually you get a sphere. Now, I just always want to point out, the sphere is not the center. Anything in the center of the sphere is just the outside. It's just the outside. So it's not all the points from the outside to the inside. It is just the points on the outside. That's what defines a sphere. 3D shape that is a collection of all points equidistant from a given point. Okay, so here's the deal. As I've said with the pyramid as well too, there's a couple shapes that I cannot prove to you. Sphere is one of them. You need calculus for that. The book goes into, I don't know, it twists and turns itself trying to prove this one without calculus. There's 2 pages of a proof there, and it says justification. It doesn't even use the word proof. It's because this one can't be proved without calculus. And when you get to calculus, either college or senior year, high school, it will be proven to you, but just not today. So we're simply going to write down the formula. This is Theorem 12.9. Theorem 12.9 says that the surface area of the sphere is equal to 4 pi r squared. Pretty simple formula. It's very elegant. It's very short. It only has one variable r, which is the radius. You square it, you multiply it times 4 and pi, boom, you're done. Pretty simple to do. The area of a sphere, that's the surface area, equals 4 times the square of the radius. Now, a lot of kids, myself included, when I first learned this intellectually causes some issues. If you think of a globe, you think about the equator. If you think about the circle that the equator is, and you pull that circle out from the sphere and lay it on top of the globe, 4 of those circles would completely cover. I don't mean a little bit. I don't mean with overhang. I don't mean like almost. I mean exactly it would cover. And for a lot of kids, that's kind of hard to wrap your head around, that why it works so perfectly. And like I said, we have to use some calculus to prove this. The book does a pretty weak job of trying to justify it without calculus, and it is a weak justification. All right, so this is only only a handful of times where you just gotta take it for granted that this is the actual formula. I can't prove this one to you. All right, so how does this work? Well, like I said, there's nothing much going on here. There's just simply an r. So all we gotta do is find the radius, square it, multiply by pi and 4, and we're done. The second one deals with the volume. This one isn't as elegant as the surface area. You saw this in 8th grade, and the volume is 4/3 pi r cubed. Why r cubed, not r squared? Well, remember, surface area is, well, as the name implies, an area, so the units are squared. And volume, because it's volume, the units are cubed. That's why the radius is squared for surface area, and it's cubed for volume. So 4/3 pi r cubed. 4/3, like I said, isn't as friendly or as elegant, but it still is a pretty simple concept, or constant, 4/3. So the math isn't as friendly for volume as it is for surface area, but it's still pretty easy. You're just multiplying by 4/3. So 2 formulas today. You just saw the 2. One is surface area, and one is volume. Tonight for homework, they can't make this too complicated because it really isn't that complicated. It's simply you take a radius, you either square it or cube it, multiply by a constant, either 4 for surface area or 4/3 for volume. And all of it, and make sure you're listening to this, all of the questions will say leave it in terms of pi, with the exception of, I'm looking at homework with the exception of number 18, I believe, and 17. 17 and 18 are the only ones where literally you're going to actually multiply by pi. All the other answers, you're just going to leave pi in the answer. So all the questions will be left in terms of pi, with the exception of 17 and 18. All right, ready to do some? Here we go. So we'll do easy, medium, hard, and very challenging one. All right, so the very easy one, here's the question. It says, find the surface area of a sphere that has a radius of 2 centimeters and leave it in terms of pi. Leave it in terms of pi. So as I said, since the question here says leave it in terms of pi, makes our life a whole lot easier. Well, from the first theorem, we have that the surface area was equal to 4 pi r squared. The question says that we have a radius of 2. So you just plug in 2 for r, plug and chug, and away you go. Let's see, 2 squared is 4. 4 times 4 is 16. We have units here. Yeah, we do centimeters. 2 times 2 is 4. 4 times 4 is 16. So we get 16 pi centimeters squared. All right, so I said that one was easy. There's a bunch of these. There's also a table as well, too. Don't freak out. The one that I would point out on the table, well, actually, let me do a volume one first, then I'll point out the table. All right, questions on the first example, the easy example. Questions on the first example, the easy one. Matt, you alive?
Barely, but yes.
Okay. All right, let's see. Let's do volume one. This is also an easy one. Just find the volume of a sphere with a radius of 2 and leave it in terms of pi. So it's the same thing, just with the volume formula. So the volume formula is 4/3 pi r cubed. We got a radius of 2. Don't overthink this. Just plug in 2 for your radius. 2 cubed, it would be, let's see, 2 times 2 times 2 is 8. 8 times 4 is 32. So we got 32/3 pi centimeters cubed. No big deal. Now that's an ugly fraction, but no big deal. It would be a big deal if you didn't have a calculator or it didn't say to leave it in terms of pi, then you would have to multiply by pi key or 3.14. There's 2 questions like that. All right. You got that, Bree? Bree, yes, no, you got it?
Yeah.
Okay, cool. I do want to point out, because this is one of the problems for homework, it gives you a radius of the square root of 2 and asks you to do surface area and volume. So let's think this through. For surface area, we have to square the square root of 2. So if we square the square root of 2, Matt, we would be left with, what's the square root of 2 squared?
2.
You got it. All right, so that one's easy. Remember, squaring gets rid of square rooting. For the volume one, though, you're going to have to cube it. So let's think this through. So if we cubed, I wrote 3, I meant 2. If you cubed the square root of 2, what would happen? Let's see. Well, we know that squaring would get rid of it. So just remember, you could write this as the square root of 2 squared times another square root of 2. And now I have 3 square roots of 2. So there's the square root of 2 cubed. We know that the square root of 2 squared is 2. So just tack on a root 2 and you're done. That's it cubed. So the square root of 2 cubed is 2 root 2. So that's not an answer, but that's just what the square root of 2 is. So that's probably the only one in the table you might have challenges on. When you cube the square root of 2, you get 2 root 2. All right. So let's do a more challenging one. Says the surface area of a sphere is 256 pi. Find the volume in terms of pi. So notice they're not giving you what you want, which is the radius here. I need the radius to calculate the volume formula. So notice it's not giving me radius, but it is giving me the surface area. So don't panic. This is just a simple algebra one. Since it gave me the surface area, well, let's look at the surface area formula. Surface area formula is 4 pi r squared, and we're told the surface area is 256 pi. So just substitute for SA 256 pi and just go to town on that algebra. Matt, what can we do to both sides? Matt, what can we do to both sides?
I'm looking at the equation.
Our goal here is to find out what the radius is. So we're going to solve for R.
I don't think my screen's working. I'm completely frozen right now.
Okay.
I may still be on the slide before.
Bree, what do you think we should do to both sides?
What?
What do you think we should do to both sides of the equation to solve for R?
Do the cube root?
So I'm on the equation on the left, and I'm trying to solve for R.
Are we trying to get rid of R?
I'm trying to get R by itself. So what I would like is to get that R right there all by itself. So what do you want me to get rid of?
Divide by 4 and pi.
Perfect, good job. All right, so if we divide both sides by 4 pi, the 4's cancel, the pi's cancel. 256 divided by 64, 256 divided by 4 is 64. Take the square root of both sides, and we would get R is equal to 8. Boom, look at that. Just a little bit of algebra, and you get to the answer. That's what we needed to solve for the equation for volume. So now just simply take that and plug that value of 8 in for R, and away you go. 8 cubed is a big number. Let's see, 8 times 8 is 64. 64 times 8 is a big number. And then we still got to multiply that by 4 as well, too, divide by 3. So you get this huge honking ugly fraction, 2048 over 3. That's fully reduced. Tack on a pi and you're done. Don't panic that it's just a weird answer, but that's the answer. So the hard ones are, instead of giving you the radius, they're going to give you some other value there, but you can solve that equation for R. Take that and plug in. That's probably about half of the homework right there. Instead of giving you R, they give you some other value. Just solve for R in your equation. Questions on that? We did 2 easy ones. We did 1 hard one. All right, here's the last one today is a challenging one. This will, as you read this, this will look like a seemingly impossible one to solve. We're going to solve it pretty easy, though, when I explain it to you. Okay, so this is like question 13 tonight for homework. All right, so here's what it states. It says a plane passes 4 centimeters. A plane passes 4 centimeters from the center of a sphere, whose radius is 7 centimeters. Find the area of the circle of the intersection. So, as always in geometry, your best bet, if you don't understand, is try to draw a picture. So let's see, it says a plane. Now, obviously, we're talking about a flat surface here. So a plane passes through a sphere, and it's 4 centimeters away from the center. So let's see if we can picture that. So there's my sphere. Now, if I pass a plane through that sphere, where the sphere and the plane intersects, well, it makes a circle. So where this plane and the sphere intersect, it makes that circle right there as indicated. Now, which way it's oriented, it doesn't really matter because you could always turn the sphere so the orientation of the circle is straight up. Not important either, but just so you understand why I put the plane physically there. I could have put the plane anywhere, but it does give me some more detail. It says that the plane is 4 centimeters away from the center of the sphere. So let's see, where's the center of the sphere? Center of the sphere is right there. And we know that the plane, let's see, the plane was right here. We know that that plane is 4 centimeters away. So let me draw that. So the plane is 4 centimeters away. There's my 4. There's only one other bit of information right there, and it says that the circle that is formed between the sphere and the plane. That's the circle indicated right there. I'm sorry, that's wrong. That the sphere has a radius of 7. It's not the circle, it's the sphere. So the sphere has a radius of 7. Now remember, from the red dot right there to any point on the sphere, well, that's equal to 7 because that's the radius of the sphere, 7 centimeters. So I could choose to draw that radius anywhere I wanted to on the sphere. Now I'm going to suspiciously, I'm going to draw it in a one location. I could draw it anywhere. I'm going to draw it right there. So I'm going from the center to where the circle intersects the sphere, and we know that that's 7 is indicated by the instructions right there. Clearly, can you see it now, Matt? You still with me?
Yes.
Can you see the picture now?
Is it a circle or a sphere?
Yes.
Yes, then I can.
So clearly, guess what shape I'm about to make right now?
Right triangle.
You got it. So there's a right triangle. Remember, to calculate the area of that circle, pi r squared, we need to know the radius. And that last piece, the piece that I'm drawing right now, well, that's the radius of that circle. So a seemingly impossible one actually ends up being, it's just a right triangle, so we can use Pythagorean theorem. So the Pythagorean theorem says that the sum of the two legs squared is equal to the sum of the hypotenuse. Well, just make sure you put your values in the right place in that formula. So let's see, that would be what? 4 squared plus x squared equals 7 squared. And simply solve that equation right there. 4 squared, 16, 7 squared, 49. Subtract 16 from both sides. Let's see, 49 minus 16 is 33. Take the square root of both sides. We get an ugly number, but don't panic. It's just the number. So the radius of that circle is root 33, root 33. All right, cool. Because that's what we needed to find the area of that circle. So the area of that circle, pi r squared, well, the radius of that circle was root 33. Plug in root 33. Squaring gets rid of square roots, so this one was not hard at all. But boy, was it complicated to get to that answer. So as I said, I believe this is question number 13 and 14. There's 2 of them like this, 13 and 14. So 13 and 14, they just simply use different numbers, but it's the same basic setup. You got a sphere, you got a plane that goes through the sphere. Plane going through a sphere makes circles, Hey, believe it or not, that's the whole darn class right there. It's no more complicated than those 2 formulas. Formula for surface area, 4 pi r squared, and formula for volume, which 4/3 pi r cubed. So as always, we'll let Matt choose. Open up your book to that ugly table and pick one, Matt, that you want to do. One through 8 is the table.
Which page is it on?
500. I should put that in my slides. I'll put that in the slide. All right.
Let's do
Pick
number
one.
4.
Let's do number 4. All right, number 4 says complete the table. It tells us the radius is this ugly number, 3/4k. So this is what the radius is, 3/4k, and we're asked to do both the surface area and volume. So that's what the radius is equal to. So let's just plug and chug. So SA, surface area over here, and then we'll do volume over here. All right, surface area is equal to 4 pi r squared. And it does want you to leave things in terms of pi. So 4 pi r squared. And we simply need to plug in 3/4 k. So 4 times pi times parentheses 3/4 k and square that number right there. Surface area is pretty easy. It's no big deal. All right, so let's square that. 3 squared is 9, 4 squared is 16, and k squared is, well, k squared. And we got to multiply that times 4 pi. Notice what a couple things are going to cancel here. So remember that's 4 over 1 pi. So the 4 would cancel, the 16 would turn into a 4. That's an ugly cancel, but you get the idea. So pi times 9 is 9 pi over 4 k squared. So we get 9 pi over 4 k squared, and that's your answer. 9 pi, and I'm writing a k. 9 pi k squared all over 4. And that is the answer to number 4. Okay. Let's see. Volume is equal to 4/3 pi r cubed. 4/3 pi r cubed. So it's the same problem. It's just got more stuff going on. 4/3 pi r cubed. So I need to cube 4/3 or 3/4. Sorry. So if I cube 3 times 3 times 3 is 27. 4 times 4 times 4. 4 times 4 is 16 times 4 is 64. So we get 27 over 64. K cubed. I'm just cubing it. And then we need to multiply that times 4/3 pi. So once again, oh, look, a whole bunch of stuff is going to cancel. We're leaving in terms of pi. So let's see. Let me do this in blue here. The 4 cancels, the 64, 4 goes into 64, what, 16 times? 3's cancel, 3 goes into 27, 9 times. So final answer, let's see, 9, and we still have a pi, we still have a k cubed. And on the denominator, we have a what, a 16, and we're done. So that wasn't too bad. Ugly answers, but that's all she wrote right there. Cool. All right, we're ending early today. It wasn't too bad. It was just those 2 formulas. If you have any questions or whatnot, make sure you send me a chat. Please stay up on your homework. Make sure you don't get lazy. We only got a couple more days of this, and we'll be all back together again. Get back to in-class learning. Once again, there's your homework. If you have any questions, send me a chat or an email. But if you guys don't have any questions, I will stop there, and you guys have a great day. See you tomorrow.